Hey guys, I want to put a quick video together to show you how to put a scatter plot together with your data. I'm seeing some students try this and you're getting close, but you're not quite there. So I'm going to show you how to do a scatter plot in Google Sheets and how to add a trend line, how to add a correlation value, which tells you how close the trend line matches the data set. And then I'm also going to show you how to put the equation on there, because the equation is very useful as well when you have a trend line. So step one, you got to make sure when you're putting data into sheets that you're organized, okay? Give it a title. So right here, what I have here is I put drop height, which is going to be my independent variable. And we're seeing the effect that it has on the bounce height, which is my dependent variable. I include the title and the units. When I put my measurements in, notice I just put numeric values. If you try to create a scatter plot with units, so if I were to put 83 inches and I were to try to create a scatter plot, it's not going to be able to recognize 83 inches. And that's why we always put the unit with the title. You just want numeric values only when you're attempting to input a scatter plot. Once you get organized, you have all your values in, you're going to select the data. You're going to go up to, again, by doing that, you click and drag and you select all the numbers and the titles. We go up to insert, we're going to go to chart. Okay, and you need to select the appropriate chart type. Okay, right now it's defaultly going to a scatter because I use scatters a lot. But you may have your chart initially open up as a line graph or a bar graph or a pie graph. You need to choose, a scatter plot. So we're going to choose scatter plot. Okay. And then from here, a couple things you need to do from here. We want to attach a trend line. We want to see if these points follow some sort of mathematical trend that can be represented by a mathematical equation. In other words, can this be modeled by some sort of mathematical equation? So we're going to go back to the chart, and under series, you're going to toggle on the trend line. Now it's going to default to linear, and I recommend trying linear first, but sometimes linear is not always the best fit. Okay, we're going to try linear. Now, how do we know how well this trend line represents the data? Is there in fact a correlation to this line? Does it match it pretty closely, or does it not match it very closely? So we have something called the correlation value. We call it the R-squared value. We're not going to go into too much detail with this. You just need to know this. The R-squared value, the closer it is to 1, the better, I should say, that the line and the equation matches the data set. So this is very good. 0.96 is very close to 1. So this line, this trend line, represents these data points quite well. Now notice the trend line doesn't go through all the points. Some students think a trend line, you're going from point to point to point to point to point. That's not a line. Okay, a trend line tries to create a best fit for all the representative points. It's very unlikely you're going to run through all those points unless you have perfect correlation to that trend line, which is unlikely, especially in a lab setting. Okay. The other thing I like to put on there, I go under label, I go to use equation, and now we actually have an equation here for us where we say, and it's going to be in your y equals mx plus b format. And so a couple of things to note here. You have your slope of 0.465, okay? The coefficient from the x value. What is the x value? It's the drop height. And then 6.86 seems to be the y-intercept. Okay, we're going to talk about the meaning of that. And then again, this would be in the y equals mx plus b format. So the y value again is the bounce height. So in other words, we could say bounce height is equal to 0.465 times the drop height plus 6.86 inches. Okay. So hopefully that helps out a little bit and can polish the creation of your scatter plots. Couple things, you know, if it bothers you, for example, that the zero value is not listed on the horizontal axis, there's things you can do for that. You can click on this. You can actually set the minimum to 0, and this just polishes it a little bit better. And then you can actually see where that y-intercept is visually. Okay. And everything else, that's kind of the minimal, right? Everything else is kind of like additional. So if you like want to style it a certain way, different colors, you want the points to look differently, you want the maximums to be different, that's up to you. Okay. But that's the bare minimum. That's what we're looking for in Sheets. Sheets is very powerful. I mean, it mirrors Microsoft Excel. This is more than just a Word document with a bunch of boxes. It's a very powerful tool to organize data and represent data. And this is probably the best way to represent the data for this experiment. If you didn't do that right away, that's fine. I mean, there's a learning curve to this on how to select and best represent the data. Okay. So hopefully that helps. Let me know if you have questions.